Okay, so the question is, are these the columns of this, are they linearly dependent or independent of each other? Okay, so what are we doing when we're looking for dependence or independence? I mean, there's the long definition, but what you're really looking for is if you do row operations on this thing, if you get all pivots linearly independent, if you get a single free variable, those vectors are dependent, okay? So let's start with our row operations and see if we end up getting a free variable or not. All right. So just on the previous problems that we've done, our first objective is to take the top row and eliminate everything in the first column, and then we can start moving over and go further. So, okay, so we'll start out with just making those guys into zeros. Okay, so the first component, I'm going to have to multiply that guy by positive 2 and add downwards. All right? So if I multiply 2 by positive 2, that's going to give me a positive 4, and a negative 3 is a 1. Okay? All right, now multiplying 1 by positive 2, that would be positive 2, and negative 1 turns into a positive 1. Okay. Positive 2 times 3 would be a 6, and then a 6 minus 4 would be a 2. All right? Next row, I'm going to multiply by negative 1, and I'm going to add downwards. So that would turn that into a negative 2. Negative 2 and a positive 1 is a negative 1. Negative 1, and the regular one, they cancel each other out. That's going to turn that thing into a 0. Okay, and then negative 3 and a 4. Oh, that's a 1. Okay, and then bottom row, we're going to have to multiply by negative 3. Now, negative 3 times 2 is a negative 6. And negative 6 plus 7 is going to turn that guy into a positive 1. Okay, negative 3 times 1. So negative 3 plus a 2 would come into a negative 1. Right? And then negative 3 times 3 would be a negative 9, and negative 9 plus 5 would be a negative 4. Okay. Great. Now you've used the top row to go down and eliminate the first column. Stop using the top row. You're never going to use it again. Don't even think about using it. Okay? It's done its job. So now we're scooting over, and we're going to use the second row to go down and turn these guys into 0. So what I'm trying to get to, let's leave the top row alone, 2, 1, 3. Let's leave this row alone. And then these were already zeros. That was our main objective. And then our new objective is to get zeros right there. Okay? Okay, so to take this row and add it to that one, that's going to give you zeros right there. Okay? That'll give you a 1 and a 3. All right, now to do this row, I'm going to have to multiply by negative 1. So negative 1 and negative 1 is a negative 2. Now a negative 2 and a negative 4 is a negative 6. Okay. So now, if I take that row, multiply by negative 2, and add it downwards, yeah, it's going to kill off the entire row. So, let's say pivot, 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 free variable. Okay? Just from this point right here, you don't even have to get it into reduced row echelon form. At this point, you know that there is a free variable. So, at that point, you can just say, okay, free variable, linearly dependent. And that's it. Once you've found the free variable, just linearly dependent. There's no reason to get it into reduced row echelon form. You're good right there.